Hi everyone, thanks for having me at React Native EU. And today I will be talking about porting your SDK to React Native and how a small team maintains 22 client SDKs. So first, I'm Dylan. I am a senior software engineer at Mux on the DevX team. That's the developer experience team. Before Mux, I was a CTO and co-founder at Crowdcast, which is a live video streaming platform. That was from about 2015, and I did that for 4 years before joining Mux. And I have a background as a full stack software engineer for the past 10 years, and specifically for the last 5 years in the video space. And right now, with COVID and everything going on, the video space is a really, really exciting place to be in. So we're seeing a lot of unprecedented growth and new people who have not done video before that are starting to learn about it and reach for it. And it's really fun because I get to talk to developers like y'all and do that every day for my job. So one product that we have at Mux is called Mux Data. And what it is it's analytics for video. So if you think of a product like New Relic that tells you how your servers are performing, or you think of a product like Google Analytics, which tells you how your landing pages are performing, Mux Data tells you how your video is performing. And when we talk about video performance, we're talking about like the quality of service. So more like the like objective quality of the video viewing experience. We're not talking about like engagement. Engagement would be more along the lines of what is the most popular segment of a particular video, or which videos are being watched more than others. So engagement is not what we're talking about here. We're talking about pure like kind of engineering performance. So the video quality metric number 1 that we're talking about is startup time. So that is when a user taps play on their device, they don't want to wait. You want to minimize the startup time. This is also referred to time to first frame. What you'll find if you're streaming video is that if your video is taking a long time to load, users are going to leave. They're going to close your app. They're going to leave your website, and they're going to go somewhere else. So it's really important if you're building a video product to minimize the startup time. The second video quality metric that we're talking about is video quality. So there's kind of two dimensions to video quality. You have downscaling, which is, you can imagine, first of all, like the container that your video plays in, that's called like the video player. So downscaling happens when you have a big piece of video, big frame, and then you're squeezing that down into a small player. And the visual quality result is that video will still look good, but the problem is you're wasting bandwidth, and that's bandwidth that you have to pay for on your servers. That's bandwidth on the user's device that you're wasting. So that's not ideal. The opposite of that is upscaling, which is perhaps worse. And the upscaling is the opposite, where you have a small video, so you can imagine like a video that's the size of a postage stamp, and you're playing it in a player that is the size of a deck of cards or the size of an iPhone. What's going to happen there is you have to upscale the video. The player is going to have to upscale the video. The visual quality is going to suffer. It'll look blocky and have a poor resolution. It'll be kind of obvious when you're looking at it that this player is like upscaling the video. So you want to kind of hit the sweet spot there, where you don't want to upscale too much, you don't want to downscale too much. You want to kind of serve the right size video for the right size of the player. And these days you're dealing with people that are watching on Apple TVs, big 4K TV sets in their living room, and then they're also watching on little tiny mobile devices and on all kinds of various networks. So this problem actually gets to be quite difficult. The next one is smoothness. So smoothness is when we track rebuffering. So rebuffering is when you're watching a video and then you see a spinner. And what happens is the player like downloads and streams as much video content as it can, and it usually keeps a buffer of video so that if you have a network problem, it can kind of catch up. But what happens when the player runs out of buffer is that it's in a rebuffering state and you'll see a spinner. And if your users are seeing a spinner when they're trying to watch your video, they are having a bad time and they are probably going to close your app or leave your product. So it's really important to track these metrics when you have a video product. So overall, what our Mux video product looks like is this is like what one particular video view looks like in our kind of UI. And you can see here, this person watched for 1.2 minutes. Overall experience score is 50 out of 100, which is quite bad, pretty poor. The video startup time was half a second, which is pretty good. The rebuffering percentage really killed them here. Out of 1.2 minutes of watching, 24% of that time was spent rebuffering. So this user was actually quite patient. I would kind of expect that people would bounce and leave if they're experiencing that much rebuffering, especially right at the beginning there of when they started watching. So this is like the example of what one view that Mux tracks looks like. But when this really gets valuable is you get tens of thousands, hundreds of thousands, millions of views, and you look at this data in aggregate, and you can see how your videos are performing on Chrome versus Safari versus Mac OS, Windows, in North America, in Australia, in Asia, and you can kind of look at all this data, and you can really kind of optimize your video delivery to increase your performance metrics. So that's kind of about Mux and the data product and what we do. And now let's talk about what this means for React Native. So the first thing to note here is that all these metrics that we're talking about, these are all client-side metrics. So we're measuring like the end user's experience from the video player. So these are not metrics that we can collect from the server side. From the server side, you can kind of tell how video is being delivered, and things like that, but you can't really tell what the user experience is from the server side. So these are all client-side metrics. So it's really important that we build SDKs in order to track these from the actual client side of the users that are watching. So this is what we did. We built an SDK for every video player. So that includes smart TVs. You see like Apple TV, Roku, Chromecast. Mobile apps have players. Android has a player called XO Player. iOS has a player called AV Player. On the web, there's a bunch of various players. You have Video.js, is kind of maybe the biggest open source one. You have the regular HTML5 video element that you might be familiar with. Google has one called Shaka Player. There's a whole bunch of players out there. And at Mux, in order to deliver this data product to our customers, we had to build an SDK for every one of these major players so that our customers can install our SDK into their player. We can monitor that playback experience. We can monitor those three metrics we're talking about, the three main ones at least. So we get a bunch of data from the video player that can help us make these informed and give our users some informed, actionable data that they can use. So in total, we maintain, last time I counted, 22 player level SDKs. And the reason I'm here today is because I'm talking about our newest one, which was for React Native Video. React Native Video seems to be the kind of like de facto video player for React Native. It's the most common one we hear about, the most commonly requested one we saw folks using. So recently we added that one on, and that's the one I worked on. So first to talk about a little bit about our SDK architecture. So I think this is important because we really don't have a big team that's working on these SDKs. So what we did is we created a core library in each of these three languages. So we have a core library in JavaScript, a core library in Objective-C, and a core library in Java. And each of those core libraries really holds all the kind of business logic of how these metrics are calculated. And then it has a kind of a defined API. And so everything's sort of abstracted. All the business logic and all the calculation of those metrics is abstracted up into the core library. And then what we do is we have like a lightweight player-specific wrapper. And this lightweight like player wrapper, that's the SDK that our customers will actually install and initialize with their player. And what happens is they initialize that SDK in their player. That lightweight wrapper, what it does is it has a dependency on one of the core libraries, and then it hooks into like the APIs and the events that are available from the player, and it just dispatches those events into the core library. So then the core library can calculate those metrics and actually make the HTTP requests to send data to the Mux Data backend. So that's how it works, and this has really allowed us to kind of move fast because Every player has different idiosyncrasies. Players name things differently. Some players will have one callback, and then some players will not have that callback, but they'll have a different one that's sort of similar. So what this allows us to do is kind of just have that thin wrapper to kind of like normalize all the events that are coming across these different players and send them into our core library. So when I started to approach this for React Native Video, my first look was like, we have a lot of SDKs for web players, and we actually have like kind of a standard HTML5 video element SDK where if you're using the HTML5 video element, and a lot of the players out there are just using the underlying video element, we can just hook directly into that element and monitor that. So my first thought was that maybe React Native Video, maybe if I put in a ref to that video component, I'll get back a object that looks like an HTML5 video element, and then this would be super easy. I can probably do this in a day, and we'll be off and running. What I found is that's not quite how it worked. It wasn't that easy. So when I grabbed a ref to the video component in React Native world, it didn't have any of the properties and methods that an HTML5 video element would have. So I was pretty out of luck with that like super easy approach. So I just decided to rewind things and start back from the beginning. So our typical workflow for building like a new web SDK is create a new SDK skeleton, pull in the Mux JavaScript core library as a dependency, and then just dive into the documentation for the player and see what callbacks we have, what APIs that player gives us, and hook into all those and just dispatch the events into the core library based on what the core library expects, so we can start tracking things. And in total, it's probably about 300, 400 lines of code for like a new web SDK. And remember, the reason we're able to do that allows us to kind of spin up new web SDKs rather quickly, because all of that complexity and business logic, it lives inside the core library. So just the individual player wrapper is pretty thin. So I tried to do this with React Native Video. So I created a new SDK skeleton, and that skeleton is really just kind of like has the build steps and things like that. Next thing I did is I pulled in the Mux JavaScript core library as a dependency, and right away it was crashing. In a React Native world, our JavaScript core library was not playing nice. So the first thing I ran into is we were using a browser API and called under window.performance.timing. And that was not available in React Native. It's looked like we were calling window.performance.timing DOM content loaded event end, and that was not available in React Native world. So we had to kind of like wrap that in a conditional, make sure we're not accessing that if it's not available. So that was an easy fix. Next thing is we were using this library platform.js. It's popular on NPM. This is a way to kind of detect browser, operating system, manufacturer, and version data like that. And this was just not working in React Native. I don't remember if it was crashing or if it was just not giving me back any useful information. So that was just not an option. But that wasn't too painful. All I had to do there was detect the platform within using React Native's tools. They have this like a platform. There's this platform module you can import from React Native, and that allows us to detect what operating system, some version information. So I was able to pull that out and then use that instead of relying on the core library to automatically detect it with platform.js. So that was fairly easy. And in total, that was really all I had to deal with. Otherwise, what I found was that React Native was actually much more compatible with the various JavaScript libraries and browser APIs that we were using than I thought it would be. I kind of thought I was going to run into a lot more things that we were using that we were kind of depending on being available in the browser. But it turned out that it was actually quite compatible. So that was fairly straightforward. Now, next step is to check the player documentation. So I pulled up the repo for React Native Video. I see all these events. I see how I have like an onload start, on progress callback. That on progress callback is really important. I have a seek event. This looks like I probably would have everything I need. I can hook into those events, and that would allow me to kind of get the right timings, and as long as I can get the playhead position, and we can kind of be able to calculate a lot of all the metrics that we need for like a base level integration. So the way I design this is with like a higher order component pattern, which is I commonly see in React. So you can see what's going on here. This is sort of like, this would be like what my SDK would export, and that the kind of end user developer would interact with. So we export a function that takes a component as an argument. And here we're calling it wrapped component, like right there on line 3. And then what we return is a new function component. So now we have a function component, and it takes all the kind of properties that the video component from React Native Video would expect. So you can pass in all the normal properties that you would pass into the video component you're using. And then what our SDK does is it kind of hooks into all the callbacks it needs, and then returns your wrapped component. And the wrapped component that it returns would be your normal video component that you were using already, but we've kind of like overridden the callbacks and hooked into them. And then you see the way we do this is like, you can still use those callbacks if you were using them in your own application, but we've kind of like just hooked into them so that we can update some local state and that we can dispatch events into our core library. And so that this is kind of end up what the public API looks like. You can see right here, line 2, import video from React Native Video. That's kind of like, if you were not using this Mux wrapper, you would just use that video element down on line 11. But then what we have on line 6, line 3, we import the Mux React Native Video library. And then on line 6, what we do is that's a function, so we pass in that video component into the function, and that returns a new function component that we're here calling Mux Video. So now on line 6, that Mux Video component, it's going to behave just like the video component that you're used to from React Native Video, but it just has some extra options for like Mux metadata, and then it's going to be just doing some monitoring and tracking for those performance metrics. So this is what I came up with, and it ends up working quite well. And it was kind of like an easy API for anyone who was using React Native Video already. If they just wanted to layer in that Mux functionality, it makes it just like a really easy way for them to do that without having to like refactor a bunch of things. And the current status of this is that it's in beta. We have a few customers using this in production, and we actually ran into a few outstanding issues that were related to some inconsistencies that we see between iOS and Android callback behavior. This wasn't totally unexpected. I imagine that's kind of like, seems to be the people in the React Native community, there seems to be like little inconsistencies here between the different operating systems. There seems to be a common theme that comes up. So that's what we ran into. Nothing's like totally blocking, but it is a couple outstanding issues that we want to get fixed before we like fully release it for general release. So right now it's in the beta state. And a little bit, I want to talk about the alternative approach. So it turns out that React Native Video, under the hood, it uses AV Player for iOS, and it uses XO Player for Android. And basically, if you're using iOS, it's kind of like really the only player that's available, and that comes baked in with iOS. And XO Player comes baked in with Android, and these are like by far the most commonly used players on these platforms. And as a result of that, we already have great support and great SDKs for those two underlying players. So what we could do, if we wanted to kind of take an alternate approach here, is we can kind of bypass React Native Video entirely, and we can just hook in to the underlying AV player on iOS, and we can hook into the underlying XO player on Android, and then we can kind of like pull in our AV player SDK and pull in our XO player SDK to do that, and just rely on those SDKs for monitoring those underlying players. And that has some benefits. The benefits of this approach is that we get to like reuse SDKs that we are already built and that we know are well supported. And the other benefit is that we can bypass React Native Video altogether and avoid those kind of cross-platform inconsistencies that we're running into. That would be kind of like the main motivation. But ultimately, we decided that we don't want to go down this path, at least not right now. And the reason for this is it's kind of twofold. So it's a little bit, in a way, it's a little philosophical, but there's also a practical aspect to why we would maybe not want to go down this approach. The first is that, like, from our SDK's perspective and from the user's perspective, the player that they're interacting with is React Native Video. The fact that React Native Video uses AV Player and uses XO Player under the hood is more of like an implementation detail. So it's more so from a philosophical perspective, like theoretical perspective, it kind of makes more sense to just interact with the actual player itself, that interact with the APIs that are given, that are exposed by that player, and not worry about how that player is doing things under the hood. And the other reason for that is, like, if we were to kind of hook into AV Player and XO Player directly, we would be really relying on how React Native Video it happens to be using those operating system players. We would be relying on how specifically React Native Video uses AV Player. And then later down the road, let's say a new version of React Native Video was released, and React Native Video doesn't have any breaking changes in their API, but that could still break our SDK because we were relying on them to use AV Player a certain way. And then if some of that kind of underlying details changed of how they were using AV Player, then that could potentially break our SDK. And then we could be in a situation where we don't have backwards compatibility. And even though React Native Video puts out a version that doesn't break any of their exposed APIs, because they change some underlying behavior, that could potentially break some of the tracking we were doing. So this alternative approach, we're not completely out on it, but that was kind of the thinking that went into it, and the reason that we would like to approach this in a way that we've done already, which is to just use the APIs that React Native Video gives us and just rely on that functionality, because we know if React Native Video releases a new version, if they change their top level APIs, that would be like a breaking change, and then we can like kind of guarantee the compatibility in a better way. So that's it. Thanks for coming to this talk. And if you're doing anything with video, I would love to talk to you. At Mux, we're kind of like all things video. This was just kind of like a small part of what we do. And part of my job is just to talk to developers who are using video every day. So if that's you, please come find me and we will chat. Thank you very much.